Hi, everyone. Thanks for joining me in this presentation. I hope everyone's healthy and safe. This is paper submission number 122, and my name is Jian, and I'm going to present to you on a paper called Reducing Corruption in Public Procurement Using Machine Learning. Here are my co-authors. So in this section, I will first introduce the policy problem that we are tackling, along with the significance of resolving this problem. Here you can see some beds in a hospital, tables and chairs in a public school, and highways between cities. So what do all these things have in common? If you remember the title of the paper, you might have guessed it right: public procurement. Public procurement is the process in which governmental agencies and authorities purchase goods and services from companies with public funds, basically with taxpayers' money. If left unregulated, however, corruption in public procurement can lead to really bad outcomes, sometimes even deadly. The picture here shows a real case in Paraguay where the roof of a school actually collapsed due to substandard materials being used during construction. Very often, when we actually observe these bad outcomes, it is already too late. For this project, we partner with the NCP, which is the National Agency for Public Procurement in Paraguay. The NCP is a governmental institution who's responsible for regulating all public procurement processes in Paraguay. So public purchases in Paraguay is really significant and accounts for almost 10% of national GDP. What the NCP seeks to achieve is to regulate and optimize the public procurement system to prevent tragedies like the school collapse from ever happening again. The NCP's ambition is to become more proactive in reducing bad outcomes and to stop corrupt practices before it becomes too late. The ultimate goal, however, so that we don't forget, is to benefit the people of Paraguay so that they are provided with quality public goods and services and that their tax money are not wasted. All public procurements in Paraguay have to go through the NCP for review, and the NCP face a time constraint when reviewing all procurements manually. Each year, the NCP receives around 10,000 public procurements for review. There are around 30 reviewers who check all of these processes manually. The reviewers make these reviews based on their experience and rule of thumbs developed over the years. However, they face a 3-day window to come up with a conclusion on whether the procurement should be allowed to proceed or not. So this is a very difficult task. And our aim in this project is to help the NCP work effectively under these time constraints by predicting the likely future outcome of these procurement processes ahead of time. This would then allow the reviewers to prioritize their review process and assess the more risky procurements first. The ability to know ahead in time whether a certain procurement is likely to have a bad outcome will be very beneficial to the NCP in its bid to monitor corrupt practices. Furthermore, more experienced reviewers can be assigned to the more risky procurements for stricter reviews. This will help increase the chances of uncovering corrupt practices and preventing bad outcomes from happening. So now that we understand what is at stake, we need to translate this policy problem into a machine learning problem. So ideally, we would like to classify each procurement as whether they are corrupt or not. The trouble with this is that corruption is usually hidden and unobserved. And we do not have well-defined labels for corruption for the machine to learn from. We hence need to look into the procurement process to see what we could use as a proxy. So here I'm going to describe an example of a public procurement process. We're going to trace, for example, how the Ministry of Education procures the construction of a new public school. The procurement contract is first passed to the NCP for review. The NCP flags any concern it may have, and the Ministry of Education will have to make the necessary amendments until these are addressed. Once this is published, private contractors can then bid for this contract. Usually this is conducted in a sealed bid auction. The best bid normally wins the contract. However, if any of the bidders feel that the terms of the contract is unfair, they could lodge a complaint. A judge would then decide whether this complaint is valid or not. If the complaint is effective, the ministry will be given a warning and made to withdraw its procurement. In this case, we found that effective complaint can be a good label for a machine learning classification problem. We think that effective complaints are appropriate labels to continue achieving our policy goal. First, some effective complaints are really genuine concerns of corruption. For example, one common corruption scheme is through narrow specification of procurement criteria. This favors one company over another, and competition is stamped out. Reviewers usually do not have specialized domain knowledge, and it will be difficult for them to detect such acts. Complaints is one channel for competitors to flag this unfair criteria. Furthermore, complaints use up a lot of the NCP's resources to deal with. Also, reviewers also explicitly look out for any signs of unfair bias within the terms and conditions. Hence, the ability to predict in advance the chances of a procurement ending up in a complaint is especially useful to the reviewers and to the NCP. We hence tweak our classification problem. Instead of looking at corruption, we classify procurements by their likelihood to receive complaints in the future. So now that we understand the problem, I'll introduce our data set. The DNCP has data on 130,000 procurement processes spanning over 13 years. This rich dataset also contains details and characteristics of these procurements. For example, what's the item procured, the contract value, agencies, review decisions, complaints, etc. Basically every step in the procurement process. The dataset also contains 300,000 documents of the actual contracts themselves, along with amendments. The NCP actually maintains detailed account of all of this data and has even made this data public on their website. So next, I'm going to describe our methodology. Here's a brief overview of our machine learning methodology. First, we perform data cleaning. It involves converting PDFs to text and then extracting text features from them. We also perform feature engineering on the metadata or characteristics data of the procurement. Then we design our cross-validation strategy so that we can test whether models are overfitting. In the third step, we look at model specifications and hyperparameters so that we can have many models to choose from. Finally, we need to design the right metrics for model selection. Our data cleaning process involves looking at the NCP's database and performing exploratory data analysis to make sure that what we learn from the data matches the NCP's understanding. We also perform feature engineering by creating various interaction terms. We also want the machine to learn from the features of the contracts themselves. Hence, we converted PDFs to text and then extracting text features from them. Luckily for us, almost 89% of the text are text extractable. 89% of the PDFs, sorry. So the rest of the PDFs, which are 11%, are scans, and we didn't convert them to text. However, we set up a dummy variable that captures whether the PDFs are scans or text, so that we don't introduce a bias in our dataset. For the text, we extract features such as number of words, the most frequent words, most unique words, using algorithms such as TF-IDFs. Finally, we'll put all of these characteristics for each public procurement process into a Postgres database, which is the semantic database shown on the slide. And we use this for machine learning. In order to sieve out overfitting models, we use a cross-validation strategy that mimics actual deployment. So let me step you through what I meant by actual deployment. So suppose we have now deployed our machine learning system and we are at time t shown here. So imagine we're live deployed. We could potentially use all of this historical data prior to this time. However, notice that there is a 90 days blind gap that we've added. This is because some of the procurements that started prior to this date have not been concluded. So we actually don't know the labels. In fact, a procurement could take up to 90 days to complete. Hence, you don't want to train on an incomplete data set. Once we train the machine learning model, we can then use this system to predict on the procurements for the year ahead, shown by the green bar to the right of T. In the next year, shown by the second fold, the year one data becomes historical data, and we repeat the training and testing process. In fact, we can do this repeatedly for 13 years of data to get an accurate sense of how the model performs over time. In our model specification, we tested 8 classification algorithms to predict the risk score of procurements. This includes random forests, extra trees, XGBoost, logistic regressions, etc. These are implemented using scikit-learn package in Python. We also designed different grids of hyperparameters for each algorithm, giving us thousands of models and hyperparameter sets. In fact, after this, defining the right metric to select what is the best model then becomes very crucial to our project. From our conversation with the NCP, procurement activities are very spiky in nature. On a good day, the reviewers are able to review all of the procurements, so no problem. However, during peak periods, the reviewer resources can only perform quality reviews on about 30% of the procurement received. And it is during this period where our machine learning system can best help them prioritize their work. For a given day, we order the procurements by their risk score generated from the classifier. And then we take the top 30% and prioritize them for close scrutiny or close review. This is then compared to the actual outcome. So in fact, this is basically the recall measure, which measures how many of the total complaints the model can actually capture. And this is calculated for the entire year in the test set. So recall aside, the consideration of bias is very important to our project. In each step of the machine learning pipeline, we might have introduced some form of bias. A significant one that we can think of would be our choice of using complaints as a proxy for corruption. In our chats with stakeholders, it was revealed to us that usually it is only worthwhile to make a complaint when stakes are high. Therefore, using complaints as a proxy for corruption hence introduces a natural bias towards higher value procurement. We also need to check for bias on other characteristics of procurements, such as type of agency, region, whether it's in the capital or in the rural areas, and product type, so on and so forth, so that we do not bias the review process with our machine learning predictions. And this is absolutely crucial. In order to understand the kind of bias that we're introducing, we make use of an open source audit toolkit developed by the Data Science for Social Good Foundation. This tool helps us audit our machine learning models for discrimination and bias. In essence, what this means is if high value procurements only make up 20% of all the procurements, but in our prediction, 80% of all the predictions are instead on high value procurements, you will know that the model is highly biased. In our model selection process, we hence not only look for models that gives us a very high recall, but we also choose one that really gives us prediction that minimizes bias and discrimination. So here I'm gonna show you our results. Here's our result. At 30% quality reviews, our best machine learning classifier actually gives a recall of 80%, as you can see on the yellow line. This is a major improvement compared to the baseline, which is that 45-degree gray line. In the random baseline, we simulate that the reviewer reviews procurements on a random first-come, first-served basis. Interestingly, as you can see on the curve, the heuristics of ordering procurements simply by value and reviewing the highest value procurement first is an excellent rule of thumb that performed equally well as our machine learning model. This is shown by the blue line that traces almost identically to our machine learning line. However, when we look at the bias audit, despite having the same performance on the recall metric, our machine learning model refer the reviewers to 30% more low-valued procurements than the heuristic would. This helps to correct for bias on procurement values, while still ensuring having a similar recall. In fact, there are known corruption schemes that purposely avoid detection by breaking down high-value procurements to many small-valued ones. So for our machine learning model, correcting for the characteristic bias, it promotes a more equitable and robust review from reviewers. In summary, while having rule of thumbs is easy to understand, also to implement, they are very rigid and has an unnecessary strong bias towards high-value procurements. In contrast, however, using machine learning coupled with the right audit, we can achieve the same recall and accuracy with a more equitable outcome. This flexibility is crucial in ensuring that the machine learning model is flexible enough to catch various forms of corruption schemes. Next, we would also like to show you how the NCP has taken our work into the implementation stage, and we suggest future work and direction of investigation. The NCP has currently integrated our product into their system. So in the slide here, you can see that this is the actual system. The arrows point towards some traffic lights, which indicate levels of risk. This is a reflection of the classifier model. So if we click into each of the procurement, you can see the details more clearly. You can see what the traffic light is, and also what the machine learning algorithm picked up on certain procurements and the factors they picked up on to show that it's a risky procurement. So in this case, it is high value. So possible next steps. We think we should focus more closely on corruption rather than complaints, but this requires more labels during review process. When we speak to DNCP, we understand that they already have an intuition for what are the corruption schemes, but they do not have the data to find that. So as a first step, they'll be getting rid of PDF contracts for more standardized and digital formats for easier data collection. We also think that adding network data would add to the richness of the analysis. We thank the Data Science for Social Good Foundation for organizing the summer fellowship program where this project was conceived, and our partner, DNCP, for data and expertise, and Warwick University and Alan Turing for the funding. Thank you.